Hello guys, welcome back to the quantity surveying workshop and to another video. In today's video we are going to be treating how to measure for the reinforcements in our staircase. And for this staircase, this is the reinforcement drawing that we've been given. I know it looks absurd but it is very easy to actually read the reinforcement drawings, and I'm going to be showing you in this video how it is done. So this reinforcement drawing is a drawing that has to give you an idea of the measurements of each reinforcement bar and how the reinforcement bar is placed in the construction of the staircase. So if you have an idea of how this reinforcement bar is placed in the construction of this staircase, then you can easily, to some extent or to some degree, calculate the total length of reinforcement that you are going to be needing to construct a particular staircase. So first things first, in order to read your reinforcement drawing, the first thing you should look at is what they call the call out. Now the call out are these markings, that's these details that they've written at the side of the drawings. So most of the time you will always see a call out, that's this information here that is sidelined either vertically or horizontally on the drawing. So before we move forward, we need to understand how to read this call out, because if you don't understand this call outs, then you cannot move forward. So as you can see here, let's take this call out as an example. You can see here 6 Y12 07 200 center towards center, and this T under is what top. So now it is telling us now that in this drawing, when they were constructing the staircase, the reinforcements used were top reinforcements and what bottom reinforcements. So now how do I read this call out? This 6 is giving you the number of the reinforcements. This Y12 is giving you the thickness of the reinforcement. That's the dimension of the thickness of the reinforcement, whether it is Y12, Y10, Y16, Y20. So that is what this Y12 stands for. If it was Y20, you will see it as what Y20. If it was Y10, you see it as Y10. Then this 07 is called what? The bar mark. Now this bar mark is a way of arranging the reinforcements into numbers. So when you are making your bar bending schedule, it is easy for you. So just like saying bar 1, bar 2, bar 3, bar 4, bar 5, bar 6, down to the last reinforcement that you have. So as you can see, this is what bar what 7. Underneath it is what bar 6, and so on and so forth. So we said that the first number here is the number of reinforcements, the number of the particular type of reinforcement you have. Y12 is the size of the reinforcement. 07 is the bar mark of the reinforcement. 200 C to C is the spacing at which these reinforcements will be placed. Then T under means that it is the top reinforcement. So now, since you understand the call out, how do we know which particular bar this call out is for? All you need to do is this. After the call out, you are going to be seeing a line. So now this, I want you to know that if it is a vertical call out, that's if the call out is written vertically, the bar is placed horizontally. And if the call out is written horizontally, the bar is placed vertically. I will come again. If your call out is written horizontally, the bar is placed vertically. if the call out is placed vertically, the bar is placed what? Horizontally. Now, this call out for bar mark 7 is written what? Horizontally. So how do we now know where the bar is? So all you need to do now is this. Since you know that this is written horizontally, there will be a horizontal line within this call out. As you can see, this is the horizontal line drawn in pencil. So all you need to do now is to trace this horizontal line. You trace down to where there is a dot on that particular line. Let's go again. As you can see, we trace. You can see the dot. So now when you see the dot, you are going to be seeing a perpendicular line along this dot. So you trace that perpendicular line. Now you can see that there's this line. If you trace it perpendicularly, you can see that there's a line like this. So now that means this line that you are seeing like this, and this is bar mark what? 7. This is bar 7. Let me come again. You trace the line for bar mark 7, you trace it to the dot, then the perpendicular line along that dot, then you remove, you trace for it. So this is the dot. You can see that there's a line perpendicular to that dot like this. This line you are seeing here is the reinforcement. So we need to calculate for this length of reinforcement here. So now after you've calculated for the length of this reinforcement here, how do we now know how this particular reinforcement will be placed? Now when you were tracing this particular line, you can see that there's a dash here. As you move, you can see another dash here. So it means that this particular reinforcement here would be along this distance from here to here at a spacing of what? 200 center towards center. I hope you understand the logic. So now all we need is the size of this reinforcement for bar 7. So if you can determine the particular length of this reinforcement, all we need to do now is to multiply it by the number which they've given us as what? 6. I hope you understand the logic. So now let's do the same thing for bar mark 6. So this is bar 6. So in bar 6, they said that we have what? 6 number of this particular bar. The thickness of the bar is Y12. The bar mark is 06. So the bar number is number 6. 200 center to center bottom bar. So you can see this is the horizontal line. You trace it to the dot. This is the dot. Are you seeing the perpendicular line there? Yes, there's a perpendicular line. So you trace the perpendicular line from this dot. You see there's a line from here to this place, a straight bar. So now all we need to do now is to determine what is the length of this straight bar, and then we record. After you find for the length of this straight bar, you multiply it by what? The number that is given to you, which is what? 6. Now in a case where you are not given the number of this particular reinforcement, how do you find for the number of this particular reinforcement? All you need to do now is you will find a means to derive the distance. As I said, if you trace this horizontal line, this horizontal call out, you will see the dot. Now within that line, you will see the placement, how the reinforcement will be placed. So you can see a dash here down to the next dash. If you can determine the distance from this dash to this dash, then divide it by your what? Spacing, 200 center to center. It will give you the number of what? The reinforcements, which in this case they've given us as 6. So there's no need to start deriving for all this, because they've already given it to you. You can only do that when maybe they don't give you your call out, or they don't give you a complete this thing, a complete call out, that is when you now start finding the number of reinforcements, which I have just told you. Let me come again. You trace the call out to the dots. If it is horizontal, like here, horizontal to the dots, then trace the perpendicular line on that dot. So you can see this perpendicular line here. This perpendicular line in black pen is the reinforcement. You can see it is a straight bar. So we need to find what is the measurement of this straight bar. If we find the measurement of this straight bar, for example, if we say that the reinforcement, the length of the reinforcement is 12 meters, or let me just say 8 meters rather, it means that we're going to be having 6 number of these 8-meter bars along this distance from here to here. That is what it simply means. Let me take one more example before we go into the calculations direct. Now, as you can see, this is a vertical call out. Now, this vertical call out, how do we read it? 10Y12 08 150 center towards center. Now, 10 means that this particular bar is 10 in number. The thickness of the bar type is Y12. What is the bar mark? This is bar number 8. What is the spacing? 150 center towards center. So it is vertical. You trace the vertical line to the dot, which is this. And as I said, vertical call out means that the reinforcement is what? Horizontal. So if this is the call out to this dot, find for the perpendicular line horizontally. You can see there's a black line here, perpendicular to that call out. So all we need to do now is to determine what is the length of this bar. Now, mind you, you are seeing this bar straight like this because it is from the plan. But mind you, the staircase is not straight like this. The staircase is straight on the landing, and then it is slanting on what? The steps side, because this particular reinforcement will be inside what? The waist, just like we have here. So you can see this reinforcement here. This reinforcement was first straight on the landing, and then it bent down. So that is why these are the things you have to keep in mind. So this bar that you are seeing here is not a straight bar. It is at first straight on the landing, then it is bent on the waist. Please, I hope you get the logic. So this part here, this box you are seeing like this, is your landing. Then these are your steps. I know it may seem confusing at first, but by practice, you will begin to understand how easy calculating for the reinforcement of drawings actually is, especially when they give you the reinforcement drawing and the call out. So going further with this little piece of information I've given, we are going to be making a bar bending schedule with it so that you can easily understand what we're going to be doing. So to make the bar bending schedule, first you have to go through your call outs and check the types of reinforcement bars used in the construction of the staircase. So as you can see from what we have here, there are 2 types of reinforcements used for this construction: Y10 and Y12. So we can start. This is call out 1. Call out 01. You can see it's Y12, 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 Y12. Here, Y12, Y12. Here, Y12. Here, Y12. Here, Y12, Y12, Y12. Then here is Y10. here y10. So for the bar bending schedule, we are going to be making a table for each kind of the reinforcement bar. So as you can see, and this table will consist of the bar mark, the number of bars, the length of the bar in meters, and the total length of the bar. Now this total length of the bar is calculated by multiplying the length of the bar by the number of that particular bar in the structure. So for example, if the length of the bar we calculated is 5 meters and we are having 10 number of that 5 meter bar in the structure, you multiply that 5 meter by the 10 number and it will give you what? 50. So the total length of that particular bar will be what? 50. So the same table you have done for y12, you'll be doing the same table for what? y10. Table consists of the bar mark, the number of bars, the length of the bar, and the total length of the bar, all in meters. To move further, we are now going to determine which of the bar mark is having y12. So let's start with bar mark 1. So we can see this is bar mark 1, it has y12. So we'll write bar mark 1. Okay, so let's just make things faster. Only bar mark 2 was made out of y10, was made out of 10 mm reinforcement bar. So we can just say from bar mark 1 to bar mark 12. So bar mark 3, bar mark 4, bar mark 5, bar mark 6, bar mark 7, bar mark 8, bar mark 9, bar mark 10, 11, and 12. Therefore, y10 would only be what? Bar mark 2. Hope you get the logic. Now, where the main work now begins is determining the length of each bar, which we're going to be doing now. So the first bar is what? Bar mark 1. That's bar 1. Now, if you look at your drawing, you will go to your drawing and then locate bar mark 1 in your callout. So in our callout, this is bar mark 1 here. Like I said before, you read the callout. So this particular bar is 10 in number, as you have here. Let me make it like this so that it can be easily read. So 10 y12 01 150 center towards center. So this particular bar would be what? 10 in number. It is y12 and it is bar mark 1. So you trace this callout now. Since we've changed the orientation of the paper, this callout now is what? Horizontal. So we'll trace horizontal to the dots, then trace the perpendicular line that you are seeing on that dot, which is this. So now this is the bar, and you can see that this bar is along the sloping side of the staircase, meaning that this bar here is sloping. You are seeing it straight like this because of the orientation of the drawing is from the plan, but on the section it is going to be what? Slant. So now, how do we find the length of this bar? We can find the length of this bar using Pythagoras theorem. Now, if you look at this bar is slanting, right? So now all we need to do now is to determine the opposites and the what? Adjacent of this bar, making this bar the hypotenuse. So if you section this bar here, this is our bar 1, which is this one. If you section it, you are going to be having a slanting bar like this. So in order for us to know what is the length of this slanting bar, I brought out the slanting bar, then I converted it into a triangle, a right angle triangle. If we know our x, that's the opposite and the adjacent, then using Pythagoras theorem we can find the length of the what? Bar. So how do we find the opposite and how do we find the adjacent? Now, the adjacent, which is this part of the bar, would be, you can find the adjacent of this triangle using the thread of the staircase. So now you know that from here to here is our thread, meaning this bar, as you can see here in the drawing, is within 1, 2, 3, 4, within what? 4 threads. Let me come again. This bar you are seeing here in the diagram is within what? 4 threads. 1, 2, 3, 4. 4 threads. And we know that the dimension of our thread is what? 333 mm. So in order to find for what this length, this adjacent is, you multiply 333, which is the length for one thread, by what? 4. So doing that, 333 times 4 will give me what? 1332. It means that the adjacent from this end of the thread to this end of the thread is what? 1332. But mind you, we are going to be deducting what? Concrete cover from the two sides here. So since we know that the length from here to here is 1332, we are going to minus 25 from both sides, because the reinforcement is not going to be showing at this edge, at the edge of the what? Step. It is going to be inside. So we are going to be assuming that we are removing concrete cover from both sides. So this is what I mean. In order to find y, which is this, we know that this reinforcement is within what? 4 threads. So we know that the length of our thread is what? 333. So 333, that's finding y, will now be what? 4 by what? 333, and that will give me what? 1332. So we'll now less what? Concrete cover, which is what? 2 by what? 25. We're assuming that the concrete cover is what? 25 mm. So that will give me what? 50. So if I less this now, and that will give me what? 1282. So this is this for our y. Now we have to find for our what? X. So x, you can see that the x is what? Vertical, meaning that the orientation for the opposite would be the riser. So like I said, this bar is within what? 4 threads, meaning that it is going to be, the elevation of this bar will be within what? 4 risers. So we know that the dimension of our riser is what? 175 mm. So to find x, we will now state that 4 times what? 175, and that will give me what? 700. So we will now less what? Concrete cover, which is 2 by what? 25, and that will give me what? 50. And doing this, it will get 650. So it means that x, is what? 650, and y is what? 1282. Now doing this, we can now find what our hypotenuse is using what? Pythagoras theorem. So we can now write, using Pythagoras theorem, can now say hypotenuse square is equal to what? This sum of the square of the two other side. That is what? 0.65 square plus what? 1.282 square. I converted it to meters. Then all square root. This one cancel this one. So here it will now be equals to what? 0.4225 plus 1.282 plus 1.6435 all square root. Which will now be equals to 4225 plus 1.6435 2.066. This will now be equal to square root of this equals to 1.44 meters. So it means that the length for bar 1 is what? 1.44 meters. Now that you've gotten this, you now go to your bar bending schedule. So the length of bar 1, as you can see here, we've calculated it as what? 1.44. So you write 1.44. And in the bar, in the call out, what is the number of this particular bar? This is bar mark 1. You can see they've given us as what? 10 in number. So the number of bars will be what? 10. So the total length of bar mark 1 will be what? 1.44 multiplied by what? 10. And that will give us what? 14.4. So the next bar we're going to be calculating for is bar mark what? 2. Now you can see that for bar mark 2, we have so as you can see for bar mark 2, the size of the bar is what? Y10. And we're going to be having 27 number of this particular bar on the rising flights so we're going to be having 27 number of this particular bar on the first flight and on the second flight. So you can see this bar mark 2, also this bar mark 2. So 27 number for the first flight, 27 number on the second flight. That will give us a total of how many? And that will give us a total of 54 number of what? Bar mark what? 2. So now, if you look at this drawing, now we know that the call out is what? Horizontal on the paper orientation like this. So now the call out is what? Horizontal. 27 Y10 bar mark 2, 250 center to center. The top, it is both top and bottom bar, and the total is what? 27 in number. So now you trace the call out to the dot. This is the dot. Trace the perpendicular line on that dot, which is this. So this line is the what? Reinforcement. So this reinforcement is a straight bar, which makes it easy to what? Calculate. So now that we know this as the reinforcement bar, how do we now determine the length of this reinforcement bar? It is very easy. All you need to do is this. Since you know that this reinforcement bar is sitting within the width of the stairs, all you need to do now is to less concrete cover from both sides, and it will give you the length of what? This reinforcement bar. So in our drawing, you can see that the plan states that the width of the stair is what? 1,200. So since we know that the length of the width of the stair is 1,200, we can calculate it by saying if width of stair is equal to what? 1200. Then we'll now less what? Concrete cover. 2 by what? 25, and that will give me what? 50. And then we close. So 1200 minus 50 will give me what? 1150 mm. So the length of this particular bar Mark 2, will now be equals to 1.15 meters. I hope you get the logic. This one was straight to the point because of it was a what? Straight bar. As mean the bar was slanting, then we'll now have to start using Pythagoras theorem. I hope you understand the logic. So you now go to your what? Bar bending schedule. Now for bar Mark 2, we are using Y10. So you go to the table for what? Y10, which is this. We know that the length we've calculated is what? 1.15. So we write the length of the bar is 1.15. So it means that if the length of bar Mark 2, which is this, if it is 1.15, it means that this same bar on the second flight, which is this, would be the same thing. Don't forget I told you that we're having this same type of bar on the first flight and on the second flight. Now look at where they place this call out. Now if you trace it to the dot, this is the reinforcement. But on this place here, that's on the second flight, if you trace it, this is the dot, but it is the same reinforcement. So instead of calculating this one again, this reinforcement that we've calculated for can serve for this reinforcement. They are the same thing. So now, if you add 27 plus 27, it will give us what? 54 in number. So it means that for bar Mark 2, the length of the bar we've calculated is 1.15 meter, and the number of bars will be what? 54. So what will be the total length? It will be 1.15 times what? 54. And that will give me what? 62.1. Doing this, we've measured for what? Bar Mark 2. The next one we're going to be measuring for is bar Mark 3. So if you look at, so you go to your drawing and locate bar Mark 3. This is bar Mark 1, this is bar Mark 2, and as you can see here is bar Mark 3. Based on the orientation of the paper, my paper is in landscape. That's the drawing paper here is in landscape. So it means that this call out now is vertical, is written vertically. So we can see 10 Y12 bar Mark 3 150 was center towards center. So now it means that this particular bar is 10 in number, and it is what? Y12. So you trace the reinforcement to the word dots, and then trace the perpendicular line on that dot. So as you can see, this bar is from here to this end. Now on the plan, it is looking straight, but the only part of the staircase that is straight is what? The landing. So it means that this bar is both a straight bar and a what? Slanting bar. So it means that this is what we're going to be having on this bar. The orientation of this bar is going to be like this. It will be a straight bar on the landing, and then it will be what? Slanting on the what? Waist, on the sloping side. So first, we are going to be calculating for what? This part. Let's name it X. Then before we now calculate for the slanting side, Y. So to calculate for the straight side X, we know that the landing is entering into the what? Wall. Like I said in my previous video when we were measuring for the concrete work. So since the concrete is entering into the wall, the reinforcement also will be entering into the wall too. So all you need to do is this: find for the width of your landing, which is from here to here. From here to here. If you find the width of your landing, our drawing says that the width of our landing is what? 1,200. As you can see here, 1,200. That's the width from here to here. So we're now going to be adding the wall thickness, which is what? 225. So let's calculate. Finding x. So length of landing is what? 1,200. So we're going to be adding what? Wall, which is what? 225, and that will give me what? 1,425. So since we've gotten this as 1,425, it means that from this edge of the landing, to this edge of the wall, will be giving us 1,425. So it means that from here to here is 1,425. Then we're going to be minusing what? Concrete cover from both sides. So since our concrete cover is 25, we'll now say less concrete cover is 2 by what? 25, and that will give me what? 50. So when you do the calculation, 1,425 minus 50 will now be equal to what? 1,375. So x will now be equals to what? This. Then we have to find for what? Y. So as you can see, our y is a what? Slanting bar. So how can we find for this slanting bar? We can now use Pythagoras what? Theorem. So first, you will now bring out the slanting bar out. If this is the slanting bar, then you convert it to a right angle triangle. So now, if the slanting bar is y, we now have to find for what? A and what? B, where A is the opposite side and B is the adjacent what? Side. So now, you go to your drawing. This is bar mark 3, right? If this is bar mark 3, you locate the dots. So this is the reinforcement here. We've already calculated for what? We've already calculated for the straight side. So now the slanting side now is throughout the what? Step. So we're going to be seeing this slanting bar from step 1 down to the last step. So to find for the what? Adjacent side, the adjacent side, we're going to be using our what? Thread. So how many steps do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 steps. So since we know that the length of our thread is what? 333, we're going to be multiplying 333 by what? 9 steps, and that will give us what? 2,997. So it means that the dimension from here, this external side here, so this part here is 2,997. That's this thread. That's for the thread, the summation of all the threads to give us the adjacent sides. Now, if you notice, we minus concrete cover for the straight side. Now, this concrete cover, we're going to be adding it to the sloping side so that it can form a link. because this bar you are seeing here are not two different bars. It is one bar bent into that shape. So this concrete cover we minus here, we are going to be adding it towards the slanting side so that it can be like it's a link. So now, since after we're adding concrete cover to this side, we are now going to be minusing concrete cover from this side, because the reinforcement at here is supposed to be inside the concrete. I hope I'm making sense. So we're now going to be adding what? Concrete cover to this edge. We will now say finding what? B. To find B, we will now say what? The length of our thread is what? 333 multiplied by what? 9. And that will give us what? 2,997. So now that we have that, we will now add concrete cover, which will be what? 25. After you now add concrete cover, which is 25, you will now less the concrete cover for this other side. So we added concrete cover here to form the link, then we will now be minusing this concrete cover here. So it's just like saying plus and minus, plus or minus. So less concrete cover 25, and that will still give us what? 2,997. So it means that the adjacent side, which is this B, will be what? 2,997. So now that we've gotten our adjacent side, we need to find for our what? Opposite side, which is A. So to find A, since we said that the B is lying on 9 threads, so it means that we are going to be finding A using the same number of what? Riser. Meaning that since we have 9 threads here, this particular bend bar, the elevation will be on what? 9 risers. So the length of our riser is what? 175. So A will now be equal to what? 9 times 175, and that will give us what? 1,575. So we will now still do the same thing we did concerning the concrete cover, because if you look at the elevation, there will not be concrete cover here, but if you look at the elevation, there will be concrete cover here, but this place there will be no concrete cover. So just do the plus and minus. If you add concrete cover here and you minus the same concrete cover here, it will give you 0. So 35 minus 25 is 0. So it means that A is going to be what? 1,575. So let me just draw the triangle here. So A is 1,575, and we calculated B as 2,009. We calculated B as 2,997. So we need to find what the hypotenuse is. So 8 square is equal to what? 1.575 square plus 2.997 square, all square roots. That's give me what? 3.39 meters. So we'll now have to find the summation of what? the straight bar and the what bent bar. So we calculated our what x, which is this, as what 1375. So we'll now have to find the sum of x plus what y will now give us what the total length of the what bar. So x is what 1375. 1375. Just put it in meters, then plus what the y, which is this, would be what 3.39. So you add the two together, 1.375 plus 3.39, and that will give me what 4.765, approximately 4.77 meters. So since you've gotten the total length of bar mark 3 as 4.77 meters, now you now go to your bar bending schedule and record it. So the length of that of bar mark 3 is 4.77, and what's the number of that particular bar? So we can see that bar mark 3 is what 10 in what number. So it means that we're going to be having 10 of this particular bar within this distance from here to here. So this line, this reinforcement will be what lined like this, 1 2 3 4 5 6 until it reaches what 10. So that's why you can see the arrow from here to here. Record bar mark 3, 10 in number. So 4.77 multiplied by 10 will now give you the total length, which is what 47.7. So now we'll now go towards bar mark what 4. Now you go to your drawing and locate where bar mark 4 is, and this is bar mark 4. You trace it to the dots. This is the dots, then the perpendicular line on that dot. So this is the reinforcement. So now what can we say about this reinforcement? You can see that this reinforcement is within both the landing, which is the straight side, and what the step, which is the slanting side. So in the same manner that we've calculated bar mark 3, we are also going to be calculating bar mark 4 like that, meaning that this is how bar mark 4 looks like. Bar mark 4 also looks like this. It's just that it will be smaller than bar mark 3. So now, how do we now go about calculating this? We can now start by saying, let's look at the landing side. This landing side does not go to the end of the landing. I will say, based off of assumption, it was just half. It entered just half of the landing. So since we've calculated the total length of our landing, that's from this edge down to into the wall, as 1425, then if we divide it by 2, it can give us the length from here to here. Then we minus our concrete cover for what one side. So let's do that. So this now will become what x, and this will become what y. So we're finding what x. So the length of the landing is what 1425. So 1425 divided by 2 is equal to 712.5. So you will now less concrete cover for this side. You less concrete cover for this side, which is 25. So less concrete cover. That will give me 687.5. So this is what x. Now you have to find for y. As you can see, this is bar mark 4. So this is the reinforcement here. So we need to calculate what's the measurement of the reinforcement from here to this end. and the slanting bar is within how many steps? 1, 2, 3, 4. So as you can see, this bar is not completely covering the fourth one, so it is half of the fourth one. So we'll just say 3.5. So 1, 2, 3, and then half of the fourth step. So in order to find for our adjacent side, we will now be multiplying the size of one step, which is 333, by 3.5. So to find B, we'll write 333 by 3.5. And that will give me 116, and that will give me 1165.5. So we will now add concrete cover for one side, which is the concrete cover for here that we minus from the straight bar. We have to add it here. So that's add concrete cover, which is 25, and that will give me 1190.5. So this is B. Now we need to find for A. Now to find A, we know that the reinforcement here is within 3.5 threads, meaning that this slanting reinforcement will have an elevation as high as 3.5 risers. So we know that our riser is 175 in measurement, so we'll multiply it 3.5 times 175, and that will give me 612.5. So we will now add concrete cover, and that will give me 637.5. So since we found our A and we found our B, we can now find Y using Pythagoras theorem. So finding Y will now be Y square is equal to 1.1905 square plus 0.6375 square, all square root. That will now be equals to 1.35 meters. So we now have to find for the summation of X and Y. So the summation will now be equals to X plus Y, and that will give us we found X as 687.5, that's 0.688 plus 1.35, and that will give us 2.04 meters. So this is our this is the length of our bar 4. So you go to your bar bending schedule and you book. The length is 2.04, and then how many of this bar 4 do we have? You go to your reinforcement drawing and you check. This is the call out, and it says they're 10 in number, so number of bar is equal to 10. So 2.04 multiplied by 10 is equal to 20.4. So doing this, you measure forward bar 4, then you go towards bar 5. So you go to your reinforcement drawing and locate bar 5. This is bar 5. So go to the dot, then this is the reinforcement drawing. So unlike bar 4, the straight bar at bar 5 cuts throughout what? The landing, the total length of the landing, while the slanting bar is as you can see, is the same as what? Bar 4. It's as much as the same length as bar 4 if you look at the drawing. So instead of wasting time calculating for this slanting length, we have already calculated for it in what? Bar 4. So all we need to do now is to calculate for this length here. So after we calculate for this length, we now add this to the known that we have here, and it will give us the total length for what? This particular what? Bar. So bar 5 is a combination of a straight bar and what? A slanting bar. We already know that y is the same as what? Bar 4, and we calculated y in bar 4 as what? 1.35 meters. So now we need to look for what? X. So in order to look for x now, what can we see? We know that the length from here to the end here, we've calculated this as what? 1,425. How did we do that? Remember, the length of our landing was 1,200, so we added what? 225, because the landing enters into what? This wall. So from here to here is 1,425. So what we're going to be doing now is we're going to be what? Minusing concrete cover from both sides. So finding x, we will now say 1,425, which is the length of our landing. We will now less concrete cover, which is what? 2 by what? 25, and that will give us what? 50. So 1,425 minus 50 will give me 1,375. So since we know that x is 1,375 and y is 1.35 meters, so we can now find the sum. Will now be equal to what? 1.35 plus what? 1.375, and that will give us what? 2.73. So this is what? The total length of what? Bar 5. Then we book. So we locate bar 5. The length is what? 2.73 meters. Then you check how many of these reinforcements do we have. You see, bar mark says that there are 10 number of 2.73 lengths of this particular bar. So we'll now measure 10. So when we, to find the total length, we'll now see 2.73 multiplied by 10, and that will give us what? 27.3. Then we move to what? Bar 6. So we are going to be measuring for bar 6, and bar 6, as you can see in the drawing, this is bar 6. 06 is, you trace the distance to the dot, and you can see this is a what? Straight vertical bar. So it's easy for us to what? Measure. All you need to do now is to find the in-to-in length of your landing. When you find the in-to-in length of your landing, don't forget that the landing, the concrete enters into the wall to some extent. So you will now be adding, if the landing enters by 25 mm, so you'll be adding 25 to both sides, right? You'll be adding 25 to both sides. So in our drawing, here, they said that the width of the landing, that's from here to here, is 2,500. So we're going to be adding an extra 25 for the part of the landing that enters into the wall. So to book, we know that the width of our landing is 2,500, right? So we are going to be adding 25, that's the projection, to both sides. That's 2 by 25, or let's just say 2 by 30. That's what we used in the concrete. So that will give us what? 60. So that will be 2,500 and what? 60. That's the total length of the landing. So we'll now deduct concrete cover from both sides. Which is 2 by what? 25, and that will give us what? 50, and that will be 2,500 and what? 10. So the total length of this particular bar is this. Bar 06 will now be equal to what? 2.51 meters. Then you go to your bar bending schedule and then you write 2.51 meters. Now you now check how many of this particular bar do we have. Since this is your bar 6, they say that we have what? 6 in number. So you now write 6. To find the total length now, we'll now say 2.51 multiplied by what? 6. And that will give me 15.06. So doing this, we've booked for what? Bar 6. Now we're going to measure it for what? Bar 7. And this is what bar 7 looks like in the drawing. So this is our bar 7. We trace it to the dot. Now if you look at this bar 7 has a certain weird shape like this, but it is very easy to measure. So if you section this particular bar, this is what you'll be having in real life, right? In real practice, this is what the bar looks like. So it's a straight bar. Then this bar you are seeing like this is a bar that spans the thickness of the slab, minusing concrete cover from both sides. Then this bar you have here is what they call a return bar, and this return bar is calculated using a formula, and that formula is what? 50D, where D is what? The thickness of the what? Reinforcement. So if this reinforcement is 12 mm reinforcement, so it will be 50 times 12. Whatever you have will be the length of this return you have here. So all you need to do now is to determine the length of this bar, determine what the length of this bar will be. To calculate for the length of this bar that is looking vertically, all you need to do is get the thickness of the slab and less concrete cover from both sides, and that will give you what? The length for this bar. And then I've told you how to find for the return bar. So let's calculate. So now to find for this length, so let me just say this bar consists of what? A, B, and C, where B is what? 2, and C is 2. So have 1 A, 2 B's, and what? 2 C's. So let's calculate for what? A. So if you look at this drawing, you can notice that the length of bar 7, which is this straight length here, is similar to the length of bar 6, which is this. So instead of recalculating this straight bar, we can just use the same measurement as this straight bar that we've calculated in bar 6. And we said that we calculated that as what? 2,510, which is 2.51 meters. So we can now say A is equal to what? 2.51 meters. So finding B, So in order to find for B, all you need to do is this. Go and check what's the thickness of your slab, or of the landing rather. So now you can see that in this section, this is the thickness of our landing here, and they're giving it to us as what? 200 mm. So you wanna see thickness of landing is equal to what? 200 mm. So we'll not be less than what? Concrete cover, which is 2 by what? 25, and that will give me what? 50. So when you do that, you'll be having what? 150, meaning that the length of B is 150 mm. So after finding that, you will now find for what? C. And I said the formula for finding C is what? 50D, where D is equal to what? The thickness of reinforcement. Which in this case, if you check our drawing, our reinforcement drawing, this is by 7. It is what? Y12 in the call out. So we will now say 50 times what? 12 will now be equals to what? 600. So since we've gotten A, B, and C, what can we do? We know that B in our drawing would be in 2 sides, here and here. So we found one side as 150, so we're multiplying it by what? 2. We found also one side of C as what? 600, so we'll be multiplying it by what? 2. So now this is what we're going to be having. A is equal to what? 2.51 meters. B will now be equals to what? 150 times 2 will give me what? 300. That's 0.30 in meters. Then C will now be equal to 2 times 600, and that will give me 1.2 meters. That's 1,200. In meters will be 1.2. So that's 1.20. So if to find the total now, you now add everything together. 2.51 plus 0.30 plus 1.20, and that will give me what? 4.01. So 4.01 is the total length of this particular bar you are seeing like this. So you go to your bar bending schedule and you book 4.01. Then what is the number of this particular bar? And the reinforcement drawing in the call out says that it is 6 in number. So you measure 6. So to find for the total length, what do? You would multiply the length of the bar by the number of the bar. So 4.01 multiplied by 6 will give me what? 12.06. So doing this, we've measured for what? Bar 7. The next one we're going to be measuring for is what? Bar 8. Now, if you look at the remaining call out, that's for bar 8, 9, 10, 11, and 12. If you notice, right, the first flight is a mirror of the second flight in this drawing. There are sometimes one flight will be longer than one. Then you have to now calculate these other flights differently. But if you look at this now, the same number of steps that we have here is the same number of steps we have here. The same dimension of the landing, it is the same throughout. It doesn't have a complex design. So now what we can now do is this. Since we've already measured for the reinforcement in the first flight, that means this call out that you're seeing here is a mirror image of the what? First flight. Now look at this. This is what? Bar 8. Trace bar 8 to the reinforcement. Now look at this. You see this reinforcement we have here? It's the same as the reinforcement we have here. Are you seeing it? Using the eye, just the normal eye, you can see that the way they drew this particular reinforcement is the same way they drew this bar 8. So it is a mirror image of what? Bar 5. And we've already measured for what? Bar 5. So instead of recalculating bar 8, we'll just take the measurement of bar 5. Similar to what? Bar 9. Look at bar 9. Trace it to the bar. You see this reinforcement bar? It is the same as this reinforcement bar here. So bar 9 is the mirror image of what? Bar 4. Similarly, bar 10. Trace it to the, you see this long bar here is the same as this long bar we have here. That means bar 10 is the mirror image of what? Bar 3. Bar 11 doesn't have a mirror image. So what we can now do is that the ones that we've already seen are mirror images, we can just what? Go and pick the values of what their mirrors were. So from the drawing, this is what you can deduce. Bar 08 is a mirror image of bar 5. Bar 9 is a mirror image of bar 4. Bar 10 is a mirror image of bar 3. And bar 12 is the mirror image of what? Bar 1. So instead of calculating bar 8, 9, 10, and 12, we are just going to be using what we've calculated before. So we go to our bar bending schedule. We said that bar 8 is a mirror image of what? Bar 5. And what do we measure as our bar 5? 2.75, 2.73. So we'll measure 2.73. Bar 9 is the mirror image of what? Bar 4. So what do we measure as our bar 4? 2.04. Bar 10 is a mirror image of what? Bar 3, which is what? 4.77. And then bar 12 is a mirror image of what? Bar 1, which is 1.44. So we'll now go and get the number of bar 8, 9, 10, and 12. And in our drawing, they say that we have 10 number for bar 8. So 10. Bar 9 is 10 in number. Bar 10 is 10 in number. Bar 12 is what? 10 in number. So if you do the arithmetic to find the total length, this will be what? 27.3. This will be what? 20.4. This will be 47.7, and this will be what? 14.4. So the last thing we have to measure for is what? Bar 11. So to find bar 11, which is this is the call out, bar 11. So we'll now trace it to the dot. Now you can see that we don't have this particular bar in the first flight, so we're going to be measuring for it separately. So now this particular bar is within how many steps? 1, 2, 3, 4, 5, 6, within 6 steps. So this bar is what? A slanting bar, because it's within the slanting side of the staircase. So we're going to be using Pythagoras theorem to find for this particular bar. So I draw out what? The triangle. So let's say the bar is Y. We need to find for A and what? B. And like I said, this bar is within what? How many steps? 6 steps. 1, 2, 3, 4, 5, 6. Within what? 6 steps. So to find for what? B, we are going to be multiplying our riser by what? 6. So it will be 6 by what? 333. And that will give us what? 1998. 98. And we then less what? Concrete cover from both sides. 2 by what? 25. And that will give me what? 50. And when we minus 50 from it, that will give us 1948. So doing this, we've gotten for our B. we now do the same thing similarly for what? A. To find for A, since the bar is within 6 steps, so we are going to be saying 6 multiplied by what? Our riser, which is 175, and that will give us what? 1050. So we'll now be lessing what? Concrete cover from both sides. I'll stood by what? 25, and that'll give me what? 50. So when we minus it, we have 1000. So since we've gotten our A and our B, we can now find Y using Pythagoras theorem. We can now say Y square is equal to what? 1.948 square plus 1.00 square, or square root. Therefore, Y will now be equal to what? 2.19 meters. So this is going to be the length of what? Bar 11. So we'll go to our what? Our reinforcement schedule and then book 2.19, and the number of this particular reinforcement in the drawing bar 11 is what? 10 in number. So we'll now write 10. So when we multiply 2.19 by 10, we're going to be having 21.9. So doing this, we've measured for what? The total length of all the reinforcements in this staircase. So now all you're going to be doing now is to what? Get the summation of this total length for what? Y12, and get the summation of what? The total length for what? Y10. So let's add all this together to get the total length for Y12. So we've calculated that the total length of our Y12 is 268.62 meters, while that of our Y10, since we have only one, we are going to be having 62.1 meters. So doing that, you've calculated for what? The total length of your reinforcement in this particular staircase. So we've come to the end of today's video, guys. I hope you had adequate knowledge from it. Please, if you did, don't forget to like, share and subscribe to this channel, because it helps the channel grow. In our next video, we're going to be treating how to measure or how to convert the total length of this reinforcement in meters to tons, because there are some times when you are going to buy reinforcement, they purchase the reinforcement either in tons or in length. So we are going to be converting this total length in meters to tons, and we are going to be converting it in what? Length, to determine what would be the total number of reinforcements we are going to be getting in the market. Thank you, and we'll see you in the next video.